Yes. Um, he's probably joining later the talk. So if you have any questions, feel free to put it in the chat. He will respond, and if I can, I can do as well. So the structure of his talk is as follows. In the beginning, he will represent a few slides on the basics of space radiations. What is it and how it impacts the human life in space? Then I will present on his behalf a few instruments that were developed in Bulgarian Academy of Science, the Space Research and Technology Institute, which were flown on different space missions, including in collaboration with Japan, US, India, and other scientists, Russian and other. Then I will present a few experiments that are going to fly this and next year, and we'll do some conclusions. So what is important to know that actually our bodies are made of stars. I don't know if people realize, many scientists know that any elements we find on Earth that are heavier than iron are not generated in our solar system. Our sun, the processes that are running in the sun can only generate elements that are heavier as iron. But anything else like gold and other elements, they're coming from stars. They are generated as an explosion of supernovas and other cosmic rays, cosmic events. So actually our body is billions of years old if we consider the elements we are created of. Think of that. We are really space species. But what is the source of cosmic radiation, especially for people on Earth? There are different major sources of radiation that face people living on Earth or flying in closed space. Galactic cosmic rays. These are mostly protons and other heavy ions coming from galactic events, star creation, and other. They're permanent source of radiation to us. They are not stopping. They are always there. The next major source is the solar cosmic rays, rays generated from the activity of our sun. Those are protons, neutrons, electrons, gamma rays, etc. They're with different intensity depending on the solar cycle. Most people don't realize that when the solar cycle is low, we have a lot of solar cosmic rays coming to us, because I'll explain that later. So it's a kind of counterintuitive that when the solar activity is high, the solar radiation on Earth is low, and the opposite. Why is that? This is because of the radiation belts and magnetic field on Earth. The Earth is very, very unique planet compared, for instance, to Mars, because we have the magnetic field. Magnetic field on Earth is the real protector of life from these very strong, disastrous cosmic events. As you know, the magnetic field can deviate the trajectories of charged particles, and then they do not reach at that intensity life on Earth. So Mars, for instance, doesn't have magnetic field, and that led to very dramatic changes in the Martian atmosphere, as you know. Because of that, all the Martian atmosphere was evaporated in space because of the solar wind, because of the other cosmic events over a few billions of years. And this is really very important. If you want to travel and live in space, we have to find a good way to protect ourselves from galactic cosmic rays, from solar system rays. There is also a lot of radiation coming from even Jupiter electrons. Jupiter is a big planet with a lot of activities. And there is even induced radiation by, for instance, charged particles that were trapped on the moon surface, also on Mars. So it is a very, very complex thing, but we have to realize that basically, although we don't recognize it, but our evolution is really based on our interaction on life with space radiation. And it is very important to realize that there is only a limited so-called habitable zone in our galactic and Milky Way, where planets can have can have life. I will not go into all details of the physics of generation and propagation of space radiation. We can find it in the presentations of Professor Dachev. It is very interesting to mention, maybe for younger colleagues as well, that even on Earth, the magnetic field that is protecting us is not uniform, and there is the so-called South Atlantic magnetic anomaly. You can see on the slide to the right. The magnetic field around the world has a change in shape which allows some charged particle to penetrate deeper into the Earth on the Earth's surface. Also, in the polar regions of Earth, magnetic fields are less, and then we have increased radiation reaching our planet, which is very interesting. People are worrying a lot, for instance, about the climate change nowadays. But one of the biggest impact that we may face is if we have change in the magnetic poles, because we don't know exactly how they are formed and fixed. If our magnetic poles they change and travel, or we create a second or third magnetic pole, that will have dramatic impact on Earth's life, because in this area where the magnetic poles exist, radiation is much stronger. This is just something to think about that. There are different properties, different levels of solar radiation, as I said, galactic, cosmic, solar magnetic rays radiation, which is a subject of very detailed study. Here is another example of the South Atlantic anomaly, in which a lot of solar cosmic rays are penetrating Earth, and they create these increased radiation zones in the ocean. You can see where is that. So if you live there, you are exposed to increased impact. There are different doses, also very interesting to know for space engineers, depending on how in which part of the process we have our hardware. For instance, you see a very interesting measurement. The dose rates when we have the satellite traveling to the spaceport, the dose rates increase on the rocket because of different sources, and then when we go into space, other factors start influencing and increase the dose. To the left, there are some examples of dosimeters that were created at Bulgarian Academy of Science. I believe this data plot is of high interest for all space engineers, because it shows what are the radiation levels in different orbits depending on the mission. If we are designing a low Earth orbit satellite, we have to design for some level of radiation robustness. If we are designing a satellite going to a higher altitudes, we have to increase the level of radiation robustness. We see what interesting is that the highest doses are seen in the radiation belt, where a lot of secondary particles are created. And to the top, you see the levels of galactic cosmic rays in the free space interplanetary range. You see to the right very interesting numbers. What are the different radiation levels and dose rates depending on where we are? If we are on Earth, our typical life environment is about 0.1 microgray per hour. See, this is our normal life. Though in some areas of Earth, because of the terrestrial radiation, we have significantly increased radiation sources, and people still live there. They adapt. Into the interplanetary space, measurements show we have about 150 times the normal rate of radiation. So you can imagine if we are living on Earth, if we are traveling in space, on the moon we have up to 100 times more radiation than on Earth. And even on Mars we have 83 times more radiation. What is the impact of radiation on human body? There are many studies from over a century since the radiation was discovered as a natural phenomena. Of course, the biggest impact has on the DNA. DNA chains are affected. And also different types of radiation impact in a different way the astronauts. For instance, galactic cosmic rays, they create a lot of secondary particles. And they also affect a lot the cosmonauts. Solar cosmic rays and radiation from the solar belts can be shielded also with the specific aluminum or other protectors. There are a lot of studies. One can see this and read this paper on the impact of the space radiation on the human body and the different effects it creates. Be aware, my colleague from Medical University will discuss some effects on the microgravity. But space is not really the best living environment for human. This is the point. We have a lot of much stronger levels of radiation that we need to cope. There are a lot of scientific results and information. I'm not going to discuss, we don't have all of this, but there will be time, but we will have the slides and you can go into the depth of all of the slides. It's important to know what I already showed, that the radiation in space is about 100 times or more higher than the radiation on Earth. So we have to take very specific protection measures if we want to live there. We cannot just go to Mars and live there as we live on Earth, because it's not only space, it's not only vacuum, but it is the radiation there. Even flying on airline creates additional radiation stress. It's not that dangerous, but we need to count for that. And there were studies how the pilots are affected by radiation. How to measure the radiation and what to do. At Space Research and Technology Institute of Bulgarian Academy of Science, Professor Dachev and his team developed different generations instruments, space dosimeters, which are small. You see different devices here, flown on different satellites and space mission, including International Space Station, Bulgarian space flight cosmonauts. You see here the very first prototype on the shuttle programs and many more. This is a work done over 40 years or even more, I think, since the 80s already. So over 40 years of research and engineering to be able to measure exactly in real time the doses the cosmonauts and equipment achieve. You see here some specific instruments, a dosimeter placed on different missions in the space station, outside, and collecting a lot of valuable information. There's a lot of detail and statistics. You can see we don't have really a lot of time here to go. This is a very heavy presentation, but we decided to keep it here just for a good reference, because we believe it is of interest to many researchers developing satellite systems. To understand that we need to develop good protection and monitor radiation. I will jump to the upcoming mission of the Lulin series of dosimeters. Even now, they are planned a few missions that are already flying in space, including into the Japanese module of the International Space Station. Japanese scientists participate in the calibration and the exact development of very precise systems. There are future projects coming with the space companies. The Virgin Galactic is using the dosimeters of Professor Dachev's team to be put on board of their shuttle. You know, if we are going to have space tourism, you need to really know very well what are the danger or what are the levels achieved by the tourists and people. So all space tourism companies have to have such systems on board. There is a database developed also that is open to researchers from different countries to use the results and plan their experiment and development. Future experiments that are ongoing. You see a few slides on the work going on with NASA, Kyushu Institute of Technology, the Japanese satellite Tenkoh, and a lot of interactions are going on between the team of Professor Dachev and researchers in different areas with Brazil on satellite, even with the Blue Origin's New Shepard rocket as part of the manned space flight crew. A lot of people contribute with a lot of effort to this work, but what is important to understand? Space is dangerous for people. We need to be very well prepared, and we need to account for space radiation. We cannot avoid it. It's very difficult to shield from that. And we have to know this part of the space environment. Professor Dachev wants to acknowledge his large number of colleagues from within Bulgaria, international, and in different activities that contributed to his work. And you see the picture of these young engineers that started some time ago this activity in Bulgaria. Now they are more experienced, but still enthusiastic to continue and move forward in the work. Feel free to contact Professor Dachev's team if you want to collaborate on the space radiation for dosimetry for different applications. Thank you very much. On his behalf,